Here we have a problem that involves potentiometer. At the same time, apply some of the Kirchhoff's laws that we've learned so far. Okay, so we have this circuit. All right. You're asked first to find the current applying the second law to circuit CXYDC. So it's this circuit. This, there, going there. Okay. So find the current using that loop. So since you're using a loop, you'll be using the second law of Kirchhoff's, where it involves the EMF, total EMF equals to the total PDs for individual resistance. So that gives you 2 volts, okay, equals to current, that's what we're looking for, multiply to all the resistance. So you have your J, your X to Y, which is 4 ohms, 4.0, plus the value of the variable resistor is 2.5, plus the value of your internal resistance, which is 0.5. Okay, so from there you can solve it already. 4.0 plus 2.5 plus 0.5. Okay, divided 2 divided by 7, so you'll get 0.29. All right, so the current now that we have is 0.29 amperes. 0.29. Okay, again, this is courtesy of the second law of Kirchhoff's. Now, on the next one, you are asked to solve for the potential difference across wire XJ. Now, we already know the current. We just don't know what is the resistance across wire XJ. So notice that you are just using not the whole wire, not X until Y, but only X until J, and it's only just zero point 0.9 meters long. Okay, so how are we going to solve this? We're just gonna solve the same way. So that's V equals to I times R. Problem is we don't know what's the R. So if, okay, XY's resistance is 4 ohms, all right, then XJ should be 0.9, okay, times 4 ohms. Okay, should be a factor of 0.9. Therefore, the XJ's resistance, okay, XJ resistance should be equal to 0.9 times 4. That gives you 3.6. Okay, given that, you can now solve for your voltage. 0.29 times 3.6, okay, you get 1.04, okay, volts. All right, now you want to find out what is your answer for, or what's the value of E using your answer in double I. The answer should be the same as double I, so that's 1.04. Why is that so? It states here that if the point J and a position of 0.90, the galvanometer doesn't have any reading. Okay? So that means the value of cell B is equal to the potential difference across this area. Alright? Now, last question is, state why the value of the internal resistance of cell B is not required for the determination of E. It's very simple. The answer is that there's no current. Since there's no current flowing there, it is not important to identify in the first place. That's how you answer the potential divider circuit.